Last time, we looked at 6 ways to multiply. This time, we'll look at 6 ways to divide. So, let's begin. Okay, so we are going to start with the method you are probably most familiar with. It's the long division method. So, we'll take a look at an example. 1,234 divided by 5. For this, copy the dividend, which is 1,234, the number you are going to divide, and put it under the long division symbol. Outside would be the number 5. Okay? And above the symbol, that's where we're going to get our quotient. So for this, we are going to take one digit at a time and divide it by 5. Since 1 is too small to be divided by 5, we'll begin with 1 and 2. So there are 2 5s in 12, so we'll write down 2 on top and multiply that with 5 to get 10, which we are going to subtract from 12. So when we subtract that, we'll get 2, and then we can bring down the next digit, which is 3. Now there are 4 5s in 23. 4 times 5 is 20, and we'll subtract that from 23, and we'll get 3. Then we can bring down the last digit, which is 4, and there are 6 5s in 34, so we can subtract 30, since 6 times 5 is 30, from 34, and we'll get the remainder 4. So we can write the answer as 246 remainder 4. Or we can also write it as a mixed number. Our answer will be 246 and 4 over 246. But we can simplify that to 246 and 2 over 123. Instead of getting a fraction or a remainder, we have another way to do this. So we'll start off from where we left with a remainder of 4, but instead of using that as a remainder, we'll concatenate, or basically add, a decimal point and a 0 at the end of our dividend. Now we can bring that 0 down and get 40. Now there are 8 5s in 40, and we can subtract 40 from 40 to get no remainder. Notice that our quotient now has a decimal point, and our answer will be 246.8. Okay, so here's the second method, is the factorization method. This method is often used for getting the greatest common factor or the least common multiple. Let's look at an example. 624 divided by 12. Now, to do this, we'll get the prime factors of your divisor, in this case 12. So the prime factors of 12 are 2 times 2 times 3. Okay, so we'll start off with 624 and use the number 2 and look at the symbol here. So it's sort of like the reverse symbol for the long division method, and we'll divide 624 by 2, so half of that is 312. Now we'll repeat the process until we run out of the prime factors of our divisor. So 312 divided by 2 is 156. 156 divided by 3 is 52, and that will be our answer. We had a lattice method in multiplication, and we'll also have a lattice method in division. So we'll look at this example here, 123 divided by 4. For this, since we have 3 digits for our dividend, we'll create 3 boxes. So the boxes should be arranged in a diagonal, and each of those boxes will be divided into 2 by a diagonal line. Okay, so we'll write down 4 on the left hand side, and above each of those boxes will be the digits of our dividend. Okay, so right now we're going to try and divide 1 by 4, but since 1 is smaller than 4, then we'll get 0, and our remainder will be 1. So our remainder is the one in blue, but notice that it will be carried over to the next digit. That's 1 and 2, which is 12. Now, how many 4s are there in 12? There are 3. Okay, and we'll have no remainder. Now, 0 and 3, it means 3. How many 4s are there in 3? We have 0. And our remainder will be 3. So notice that our answer will be the one in yellow. It's 0, 3, 0. We can basically just ignore the first 0, so get 30 with a remainder of 3. Since we had an Egyptian method for multiplication, we must also have an Egyptian method for division. So the method is pretty similar. We'll take a look at an example, 621 divided by 23. Similar to the multiplication method, we'll write the numbers in separate columns. So in this case, we'll start off with the right hand side instead of the left hand side. What we do is copy the number and keep on doubling it. 23 doubled is 46, double that is 92, double that is 184, double that is 368, double that is 736. But we only need the numbers that are smaller than 621. So we can disregard 736. Now, on the left hand side, we have to write the number 1 and keep on doubling that until we reach the last row with a corresponding number at the right hand side. Okay, so double 1 is 2, double 2 is 4, double 4 is 8, double 8 is 16, and we'll stop there. Okay, so now what we have to do is determine what are the numbers on the right hand side that will add up to 621. Now, for this method, we'll have to start from the bottom since that's going to be the largest number. 368 plus 184 is 552. Okay, so it's still smaller than 621. So we can continue. So add 92, we'll get 644. Now that is already too big. So we can slash that off. Okay, so how about if we add 46? Adding 46 will give us 598, which is still smaller than 621. So we add 23, and lo and behold, we get 621. Now we'll get the digits from the left hand side that are not cancelled. So 1, 2, 8, and 16, because 4 has already been cancelled, and we add those up. Now when we add those up, we'll get 27, and that's our quotient. So 621 divided by 23 is 27. So this next method is called the box method. This is most often used for teaching younger kids how to do division. So let's look at an example, 654 divided by 3. Since this is the box method, naturally we'll start with a box. And we'll divide the box into how many digits there are with a dividend. Since there are 3 digits in the dividend, we'll divide it into 3. And we'll write each digit of the dividend in each column. We'll write the divisor outside and determine how many 3's go in 6. So there are 2. 2 times 3 is 6, and we'll subtract that from 6, and we'll have no remainder. then we move on to the next column. How many 3's go into 5? Only 1. So we'll subtract 3 from 5 and we'll get a remainder of 2. We'll carry that 2 over to the next column. So how many 3's go into 24? Well, there are 8. So 3 times 8 is 24, and we subtract that, and we'll be left with 0. And our answer will be 218. I probably saved the best for last. This is called the Greek method. It's actually a method by Hippocrates, not the physician, but Hippocrates of Chios, who lived about the same time. We'll look at a simple example, 12 divided by 3. In this method, we'll need to construct lines and we'll divide them into intervals, okay? So we'll actually use 2 lines. It doesn't even matter what the angle is, as long as it's an acute angle, okay? So here we have 12 divided by 3. We need to make a line that intersects both 3 and 12, okay? But notice that I am using here a rectangle, and I have a reason why, okay? This rectangle is the easiest way to get a parallel line, okay? So we can mark the 3 and the 12. That's where they intersect. But look at where 1 intersects with, okay? So that line goes straight and it intersects at the number 4. That intersection is where our quotient will be. So I didn't include this in the method for multiplying, but you can see that this will be easily applied to multiplication as well. So just do things in reverse. It's probably no wonder why Greek mathematicians didn't really do much on numeracy, but they did a lot on geometry. Just take a look at the work of Euclid. I hope you enjoyed this video and learned something new. If you did, click on that like button and subscribe to our channel so you don't miss out on any of our videos. Also, you might be interested in Math and Magic, Bringing the Magic of Math to Class by Mr. E. It is an interactive ebook where you can learn mental math techniques and some cool magic tricks to perform. You can get a copy exclusively from Amazon. Links are in the description down below. Thanks for watching, and I'll see you in the next video.